In this video, bipolar junction transistor characteristics, both static characteristics and dynamic characteristics, and its structure we will see. So first of all, we must know what is construction of power BJT. So it is different from normal small signal BJT, which is used in small basic electronic applications. So here we have the layers of BJT is 4 layers. The first layer is heavily doped emitter. The uppermost portion is N plus, which is doped with 10 power 19 electrons per centimeter cube. So it is heavily doped in the uppermost portion. And the second layer is moderately doped with a base. So this is called a base. This element is the base, which is lightly doped with a 10 power 16 holes per centimeter cube. And the third region is called that is called collector region. That is very lightly doped with a 10 power 14 electrons per centimeter cube. And the bottommost portion is also doped with the electrons, but with a high concentration of 10 power 19 electrons per centimeter cube. So of course it is three different elements, that is NPN transistor, but the doping in the bottom side is made with a different concentration, N minus and the N plus. N plus meaning that it is heavily doped, highly doped. And as we know, the circuit symbol of the transistor is NPN transistor, which is and another one is a PNP transistor. So this we know very well. Now coming to the static characteristics. So this is the static characteristics, that is output collector current and collector to emitter voltage is the graph is drawn. That is called static characteristics, which is having 4 regions. The first region is called cutoff region, where nothing is happened. So the bottommost portion is called cutoff region. So where nothing is happening, it is called top region. And the second region is called the active region. So this active region, this entire area is called as active region. So in this region is applied only for amplifier circuits. So for the amplifier circuit, we are using the transistor, a BJT transistor, so which is operated at the active region. So this area we are not focusing. So this will be purely deal with the electronic circuits like amplifier, oscillators. So those circuits only it is needed. So we are not focusing much on that. And the third region is third region is called quasi saturation region. So it is called quasi saturation. It is a region where after some arrangement this becomes hot saturation region. So this entire region is nothing but we will take different colors. This entire region is nothing but a saturation region. So in this region only the transistor has to be operate as far as a power electronic circuit consider. So when we use any BJT in the power electronic circuit, we must operate in the saturation region, where the current voltage, suppose you make the drop down here, so which is having the lesser voltage, but high current. So the current is somewhat high. So that means the current flow is there, but voltage drop is less. So we must operate always in the saturation region for using the BJT in the power electronic circuit. And the next one is switching characteristics of a BJT. To study the switching characteristic, we need the circuit like this. So this is called the NPN transistor, and the base is given with a train of pulses. So here we have the train of pulses we are giving. A train of pulses is given to the base of the transistor, and the graph is drawn between a collector, that is collector current, and collective to emitter voltage that we have seen previously. Now we need to understand the switching character, how this switching of the transistor is happening, that we will see with the graphs. Now here this is nothing but a train of pulse that is given as the base supply. So this would be on and off like this, it is going. So this train of pulses given to the base supply. When the pulse is high, when the pulse is there is it is travel when the pulse is travel in positive direction, that time there will be base current. When the base current is flowing, the collector, that is the collector current is also increases correspondingly. When the base is current flowing, the collector current also corresponding increasing properly. It will follow the curve called a linear fashion. So we have different terms called a delay time, rise time, and Tn is nothing but conduction time, and this Tf is called a fall time. So combined together, this dt and Tr we can combine it together on time, that is on time of the transistor, that is equal to Tt plus, that is a delay time, plus rise time. Rise time. So delay time is the time taken by the collector current reaching from zero current to 10% of the saturation current. So this is the area where we have the delay time. So delay time is 0% to the 10% of the, here it is given, no, 10% of the collector saturation current. So this area, it is called a delay time. Now when we consider this rise time, this is from this point to this point, that is 10% to 90%, 10% of saturation current to the 90% of the saturated current. So this time interval we can call it as rise time. And conduction time, it is Tn is called the conduction time. It is a original time by which this transistor is conducting. So this we can call it as conduction time, right? Now when the base supply is going into the negative side, simultaneously the base current also, the base supply is given to the negative side, similarly the base current is also going to the negative side. So again the conduction, the collector current is gradually reduces. So this area we can call it as off time, that is called a T off equal to Ts plus Tf plus Tf. Tf plus Tf. So again we noted this is just opposite to the rise time and the delay time. Ds is opposite to the Dr, and the Tf is opposite to delay time. So after some time this Tf is nothing opposite to the Tr, and just the current is fall from 90% to 10%. Again the last time it will take some time. This is called a final fall time, where we have the current is reduced from 10% to 0%. So this is a final fall time. So again we must understand a different timing, that is a delay time, rise time, and fall time, and of course Tn is the conduction time. So to study the switching characteristics, these are all the things we must know.